am Sreja MR, working as lecturer in Department of Polymer Technology, Karnataka Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, I am undertaking the course of Elements of Chemical Engineering for 3rd semester. Now we will come to the slides. The portions which are discussed today are definition of fluids, compressible and incompressible fluids, physical property of fluids, fluid static and pressure concept, manometer, test, multiple choice questions or MCQs. Now we are coming to fluids. What are fluids? Or definition of fluids. A fluid is a substance which is capable of flowing. Take an example of water. Water is capable of flowing. So any fluid is a material which flows or which is able to flow. Second, it has no definite shape of its own. It takes the shape of the container vessel. We know if water is poured in a jug, it takes the shape of jug. If it is poured in water, it takes the shape of, if it is poured in glass, it takes the shape of the glass. So, a fluid is a substance which takes the shape of the container vessel in which it is placed. Then it undergoes continuous deformation when subjected to shearing force. So, whenever a force is applied to a fluid, it changes its deformation or a deformation occurs to the fluid. Examples of fluids are liquids and gases. Next, we are coming to compressible and incompressible fluids. What is a compressible fluid? We know fluid gets affected by changes in temperature and pressure. If a density of the fluid is affected by changes in temperature and pressure, the fluid is said to be compressible. Means if we change the temperature, pressure, or if we apply an external force on a fluid, if the density of the fluid changes, then it is said to be a compressible fluid. Incompressible fluid. Let me read the slide. If the density of the fluid is insensitive to moderate changes in temperature and pressure, the fluid is said to be incompressible. Example, liquids. So, if the temperature, pressure or any external force does not affect the density of the fluid, then it is said to be incompressible fluid. For example, liquids. If we exert any pressure on liquids, the density of liquid does not change. Density of water does not change. Example for compressible fluids are gases, and example for incompressible fluids are liquids. Now coming to physical property of liquids. The main three properties discussed here are density, specific gravity and viscosity. Density, specific gravity and viscosity. Physical property of fluids, density. What is density? Density, it is denoted by rho of a fluid is the mass of the fluid per unit volume. So, it is mass divided by volume. Amount of fluid which is there present in unit volume of area. The SI system, it is expressed as kilogram per meter cube. For mass, the unit is kilogram, and for volume, the unit is meter cube. So, SI unit of density is kilogram per meter cube. Density, the formula for density is mass by volume. Then density of water is 1000 kilogram per meter cube. This is the density of water. So density of a material or a fluid is the mass of the fluid per unit volume. Next slide, we are going through viscosity. So viscosity, what is viscosity? Viscosity is resistance to flow. If any fluid offers resistance to the flow, it is called viscosity. It's a measure of resistance to flow. It's also resistance offered by a fluid to continuous deformation when subjected to shear stress or force. When a liquid is flowing or a fluid is flowing, we can consider the fluid as layers. Due to its internal friction, they apply a force opposite to flow to resist the flow. That is termed as viscosity. It is independent of pressure, but viscosity depends on temperature. For gases, when temperature is decreased, viscosity is resistance to flow. In liquids, if temperature is increased, the viscosity of the material decreases. The SI system of viscosity is Newton second per meter square. Now next we are going to specific gravity. What is specific gravity? It is defined as ratio of weight density of fluid to weight density of standard fluid. Means it's a ratio. Specific gravity is a ratio. It's a comparison of weight density of a particular material. If we are taking weight density of mercury to weight density of standard fluid. Standard fluid mainly used as water. For liquids, water is used as a standard fluid, and for gases, air is used as a standard fluid. So specific gravity is ratio of weight density of the fluid to weight density of standard fluid. The standard fluid used is water. It's also called relative density. Since it is density of one fluid is compared to density of water, it is called relative density. And since it is a comparison, it doesn't have any ratio. It is a dimensionless quantity. It is denoted by S. Now coming to fluid static pressure concept. So fluids under static pressure, static state, exert as pressure. We are now dealing with fluid which is not fluid, which is under the static state. So the forces exerted by static fluid always act in direction to normal to the surface of contact. A static fluid always puts force or acts normal to the surface of contact. If normal forces exerted by a fluid per unit area of the surface is called fluid pressure. In a fluid, if a fluid is applying forces normal to unit area, it is called fluid pressure. Pressure is given by force per area. If a fluid is placed in a container, then forces exerted by the fluid per unit area of the surface is called fluid pressure. For a static fluid, the forces exerted by the fluid is called the fluid pressure. It is force per area. What is pressure head? Pressure head is the vertical height or the free surface above any point in a liquid at rest is called pressure head. If a fluid is there in a column, then the total height of the fluid in the column is taken as pressure head. If a point is middle of the container, then the vertical height above that point is taken as the pressure head. Pressure head is denoted by H equal to P by rho G. Here H is the pressure head which is expressed in meters. P is the pressure exerted, rho the density of the fluid, and G acceleration due to gravity. So pressure head of any liquid column can be denoted by pressure divided by density into G. The unit of H are meters of liquid. It is expressed as meters. So what is pressure head? It is the vertical height or free surface above which the liquid is at rest. Is called the pressure head. The pressure head is expressed as meters of liquid column. Now we are coming to manometer. What's a manometer? Manometers are instruments or used to measure pressure. Simple instruments which are used to measure pressure. What's the manometer? They are simple pressure measuring devices. They are used for measuring low pressure or pressure differences. Pressure is measured by balancing with another column of fluid. So, a simple manometer is a small glass tube type material. It has a fluid called the manometric fluid. It can be mercury, oil. Most probably mercury is used as the manometric fluid. Then it is by using help of atmospheric pressure, we are measuring the pressure of the material of the liquid which is to be measured. Pressure is to be measured. It is measured by balancing another column of fluid. If a fluid, this manometer is connected to the place where pressure is to be measured, and by balancing both the liquids we get the pressure or differences in pressure. So the liquid which is used inside the manometer is called manometric fluid. Manometric fluid. So this is the simple manometer diagram. So we can see the blue part, it is called the manometric fluid. Meaning mercury is used as the manometric fluid. Two parts are open. One part is connected to the place where pressure is to be measured. Any pipe whose pressure or is to be measured, this first part is connected, this yellow part. Then second part, it is open to the atmosphere. So we have a glass type tube of small diameter. It's having a manometric fluid and one part is connected to the point where pressure is to be measured. Another part is open to the atmosphere. There is a scale placed. This tube might be clamped to the wooden platform. The scale is placed where we can note the height of the manometric fluid according to changes in pressure. So this H is called the pressure head. Manometric fluid. So manometric fluid is the fluid which is used inside the manometer. Typical filling liquids commonly used for manometers and their densities. water of density 1000 kg per meter cube, oil whose density can be between 800 to 950 kg per meter cube, and mercury whose density is around 13,560 kg per meter cube are the commonly used manometric fluids. Now U-tube manometer. U-tube manometer, as previously shown in the figure, is the simplest form, or this is a U-tube manometer. This can be considered as a U-tube manometer. This is the simplest form of manometer. It consists of, as I had explained earlier, it consists of a small diameter U-shaped tube of glass. It has a very small diameter and it has a U-shaped glass material. The tube is clamped on a wooden board. The tube is clamped on a wooden board. The scale is fixed on the same board for getting the reading of pressure head. Now this is a U-tube manometer, simple diagram of U-tube manometer. You can see in this diagram, one blue part is there, one red part is there. In blue part is the liquid whose pressure is to be measured, and red is the manometric fluid. So one part of the U-tube manometer is connected to the pipe whose pressure is to be measured. It is denoted by A. Then we have a datum line. It is AA is the datum line. Here both points, say 2 and 3, the pressure will be equal. Pressure of point 2 will be equal to pressure at point 3. Now we can see, due to pressure, this manometric fluid has shifted, and we can get the reading of height of manometric fluid as H2 and height of the liquid column up to the datum line as H1. This is a simple U-tube manometer. Fluid to be measured, point A pressure is to be noted, AA is the datum line, and it contains a manometric fluid. One end is open to the atmosphere. H1 is the height of the liquid column above the datum line, and H2 is the height of the manometric fluid. Coming to the next slide, U-tube manometer. U-tube manometer, the common manometric fluid used is mercury. Most commonly used is mercury. The two sides are connected by tubing to the tabs between which pressure drop is measured. So, one U-tube manometer, two sides. If pressure difference is to be measured, it is connected to the two ends where pressure drop is to be measured. And it is connected to tubings or tabs. Consider AA as the reference line. Here pressure is equal. Here AA, the reference line, where both pressure on left side is equal to pressure on right hand end. Pressure on the left limb is equal to pressure on the right limb. AA is the datum or reference line. Now, getting to the point, with reference to datum line, we have PA, that is pressure at A. Then rho 1 G H1. This is rho 2G H2. Rho 1 is the density of the fluid whose pressure has to be measured. G is the acceleration due to gravity. P is the pressure which we have to measure. H1 is the height of the column of fluid whose pressure is to be measured. Rho 2 we are taking as mercury, as rho 2 is the specific density of mercury. H2 is the pressure head or height of the mercury column, and G is the acceleration due to gravity. PA is the pressure to be measured. Rho 1 is the density of the material pressure is to measure. Rho 2 is the specific density of mercury. H2 is the height of the mercury column. H1 is the height of the liquid whose density is to be measured. So with reference to this line, PA, pressure at A, plus here both pressures are active. Pressure at A plus pressure due to liquid in the tube with height H1. That both when these both are added, it is equal to pressure in the right leg or pressure of mercury head. That is rho 2 H2 into G. So pressure at A is equal to rho 2 H2 G minus rho 1 G H1. P is the pressure of the liquid to be measured. Rho 1 is the density of fluid whose pressure is to be measured. H1 is the height of the tube above the reference line of the first liquid whose pressure is to be measured. Rho 2 H2 are the density and height of mercury in the U-tube. That is the red part, mercury. Now inverted U-tube manometer. In inverted U-tube manometer, it consists of a U-tube which is inverted. See, this diagram shows the inverted U-tube manometer. And there is a manometric fluid. It will have a density lighter than the other two which density has to be measured. Then both ends are connected to different points whose density is to be measured. So inverted U-tube manometer, it consists of an inverted U-tube containing the light liquid. So it has as shown in the diagram, it has an inverted U-tube containing a very light liquid. Two ends of that inverted U-tube manometer are connected to 2 points whose difference of pressure is to be measured. It is used to measure low pressure differences. So, delta P or difference in pressure can be given by P1 minus P2, which is rho m, density of manometric fluid, H into G. So, delta P means P1 minus P2, difference in pressure, can be measured by the simple formula rho m Hg. Rho m is the density of the manometric fluid filled in the tube, H is the height or pressure head, and G is the acceleration due to gravity. And this H in an inverted U-tube manometer is H1 minus H2. h1 minus h2. h1 is the height of the datum level. If this is taken as xx, h1 is the height of the datum level till the base, and h2 is the height of the liquid till the base. Not liquid, it is the height of the manometric level, reading of the manometric level to datum. So this much area, this much length is the height h1 minus h2. So this inverted U-tube manometer is used to measure pressure differences. A light fluid is used, and it has to be connected to 2 points whose pressure difference is to be measured. Now we are coming to multiple choice questions. Which of the following is a compressible fluid? A. Hydrogen, B. Water, C. Oil, D. Sand. Which of the following is a compressible fluid? Here are the options. Now the answer is hydrogen. Compressible fluid, we had studied that gases come under compressible fluids whose density changes with respect to temperature change or pressure change, or when some external forces are applied. Now coming to second question, what is the unit for density? Options: meter per second squared, kilogram per meter cube, Newton per meter squared, Newton per meter squared. Then the unit for density, the answer is kilogram per meter cube. And third one, the normal force exerted by a fluid per unit area of surface is called dash. Pressure, fluid pressure, pressure head, viscosity. Answer is fluid pressure. If the density of a fluid is affected by changes in temperature and pressure, the fluid is said to be dash. If density is affected by changes in temperature and pressure, the fluid is said to be dash. Options: incompressible fluid, compressible fluid, Newtonian fluid, non-Newtonian fluid. The answer is compressible fluid. What is the term used for resistance of fluid to shear deformation? A. Density, B. Viscosity, C. Specific gravity, D. Shear rate. The answer is viscosity. Now this is the end of the session 1. Thank you.